So first question, where are we at? Yeah, so that's a pretty good setup. Given an air mass with a relative humidity of 40% and a temperature of 25 Celsius, what's the air mass's specific humidity? If it warms up to 35 Celsius, what will its new relative humidity be? So, hey, morning, Wyatt.
Morning, how you doing?
I'm good. better than you.
Yeah.
Okay, so looking at that part, Nicole, you good with question one?
Yeah, I think so, because you're just finding the percentage of the maximum specific humidity and then using that to find the relative humidity.
Right. So,
Newman.
what's the max specific humidity at 25 Celsius?
Let me go back to my notes. The screen is full now, so I can minimize this. Yeah, I can. At 25 degrees Celsius, we're at 20 grams.
Okay. So, and I'm just gonna start putting the answers to stuff in bold red so that it stands out. Okay,
Cool.
So then we know the relative humidity is 40%. So what's the specific humidity then?
8.
So
No.
4 times.
Yeah. Wait.
Do you have a calculator?
Yeah.
Calculator's your friend.
8.
I like it.
Okay. Good. That's what I answered on that one.
Okay, so now we've got 8 grams. So if, easy. Okay, so the specific humidity is 8 grams. So if that warms up to 35, what's the new relative humidity?
So then we have to find, for 35 would be 36.4. So then we would go 8 divided by 36.4.
Yep.
And then I got 21.978. But I rounded up to 22.
Oh, don't do that. Do that and then equals, so is that right? At 35, 36.4, yep. So 8, enter 36.4, divide, equals, yeah, 0.219 equals 22%. Yeah.
Okay, cool.
Love it.
That one I got.
I like that. Oh.
That was the only one that I really felt good about.
Well, because the rest of them, I think if you just, I mean, I realize that if you look at it all at once like that, that's a lot. But if you go through it step by step, I don't think, I mean, there's nothing in it that should be itself challenging. I think it's just keeping track of everything. So with different numbers, what do we, and I just put everything up at once and then I thought we'd go through it and break it down bit by bit because that's the way I would do it.
Cool.
So we've got air mass outside your house. We know its temperature. We know its relative humidity. So we want to find the specific humidity and dew point. And then if we bring that warm air into the house and cool it, you're going to get condensation. Oh yeah. And on the, I just realized this morning that I have the order of these backwards, that if you do that in that order, it's much easier. Yeah, but we'll still go through it step by step. Right, because the first thing we wanted to find out is what's perfect air. What's the specific humidity for perfect air, air at 21 Celsius with 50% relative humidity. And then if we bring in the air from outside, it's going to cool to 21. We're going to get a bunch of condensation. But that's going to be, that would be 100% relative humidity at 21 degrees, but we want to bring it down to 50% relative humidity. So how much do we have to take out? So let's go through it step by step. So what do we know? We know it's 35 Celsius and the relative humidity is 95%. So what's the specific humidity?
Okay.
So we know the relative humidity, right?
Correct.
So that's 0.95. And then the max specific humidity, oh, at 35 again. Yeah, we know that because we already saw that.
Yeah, 36.4.
So equals maximum specific humidity equals 36.4.
36.4 times 0.95. 34.58.
36. I don't know. I just made up the numbers. I haven't done it yet.
Yeah, 34.58.
So I get,
So,
I get
35.
equals 34.58 equals, 35 grams. Or actually 30, the specific humidity, I think I want rounded to 1 decimal place. So that would be 34.6.
That one rounded to 1. So, okay, I got it.
So that the rounding's consistent. Wyatt, if I'm assuming you're doing okay, feel free to pipe up if you're not. So, okay, so now.
I was just completely stumped when I was doing the lab. So I'm just kind of listening over, trying to see how things kind of play out.
Right on. Were you here for the first one then?
I wasn't here for the first one, but I was able to catch enough to realize what you guys were doing.
Okay. I think that one, if you're good with that one, I'll just keep rolling then.
Yeah.
Okay, so now we want to know, we've got 34.6 grams. So what's the dew point temperature?
So where's my little thingy for 2?
Oh, that's easy. Okay, cool.
30.
At least I think it's easy.
Did you give us you gave us a dew point thing in our notes?
Well, that's interesting.
What?
Your comment is interesting. So I'm assuming you've seen this, the maximum specific humidity chart.
Yeah.
Okay, there's a sheet 2 on it. If you click on sheet 2,
It's the dew point.
it
Yeah.
says, right? So if you've got a chart of maximum specific humidity, you've got a dew point chart.
Wait. I downloaded it, but it doesn't have a page 2.
Yeah, well, it is online. I mean, it's a
Oh.
different sheet. So
I mean, I have it in the slides. It's the same thing, I believe, right?
Oh, I should just put, yeah, it should be.
I mean, I can pull this other one up too.
Okay, so if I told you that you've got 48.7 grams per kilogram, you know the dew point is 40.
Yeah.
So if you've got the maximum specific humidity chart, you've got the dew point chart. It works both ways. At 25 Celsius, the maximum specific humidity is 20 grams, right?
Right.
So if I told you that the dew point, or if I told you that the specific humidity of the parcel is 20 grams, the dew point temperature is 25.
Correct.
So if you have the maximum specific humidity chart, you always have the dew point chart, because if you know how many grams, you know what the dew point temperature is.
Got it. And I found the online version, so that's way easier because I can click between the sheets, so that's good.
Well, the sheet only had that little read. I just added it to the maximum specific humidity chart, so it's there on both places now.
Oh, okay, cool.
Okay, so the dew point temperature, if we got 34.6, the dew point temperature is?
35, between 30 and 35? No?
Well, yes, in reality, yes, but we're just going to say it's 34.
Okay.
And I don't remember where I put that in, but I had to put that in someplace because somebody asked me a question. I'm all, oh, well, yeah, it's obvious to me who's been doing it for 20. So if it has 34.6 grams, right, and you cool it to 35, it's not going to condense,
Okay.
right?
Yeah.
But if you cool it to 34, you're going to get condensation. So just cool it. Find the temperature. How the fuck do you
Got
do
it.
that then? Oh, good. Yeah, I'm recording this, so yeah. Oops. Whatevs. So if it's 34.6, you wouldn't have condensation at 35 degrees, but you would at 34. So that's the number we're going to use.
Okay.
So like if I said we had 22 grams of water vapor, what's the dew point temperature if you had 22 grams of water vapor per kilogram of air? 22 grams. 22 grams.
26.
Yeah, because you wouldn't have condensation at 27, but if you cool it to 26, you're going to get, so we'll just use 26.
Okay.
Okay, so the new dew point temperature is 34. Okay. Do I need any of these numbers? Yeah, I'm just going to copy that and take it with me to the next page. Yeah. So the outside air has 34.6 grams per kilogram, right?
Mm-hmm.
Oh, yeah, this is the part that I did backwards. So I'm going to reverse the order of those two questions so that we can find the answers in a way that makes sense. So we know the outside air has 34.6 grams per kilogram, because we figured that out on the last page, right?
Mm-hmm.
Okay, so for optimal comfort, inside air should be 21 Celsius with 50% relative humidity. So what is the specific humidity of air at 21 Celsius with 50% relative humidity?
And then I'm gonna go back to sheet 1.
I have a quick question on that dew point one.
Yeah,
So when I go to that chart, it has 36.4 exactly at 35.
yeah, but we've got 34.6. I did the same thing, Wyatt.
Oh, okay. Yeah. Okay.
I looked at them all. Wait, it can't be 35 because the air. Oh, right. Because yeah, I was numerically dyslexic briefly.
Yeah. Same here.
Okay, so 21 degrees Celsius
Uh-huh.
with 50% relative humidity. So 51.
I will be so happy if the rest of this entire session consists of me asking you questions and you saying, oh yeah, it's.
Yeah, I'm gonna try. I'm gonna try on this
Well,
one.
and if not, I mean, I think that what was the dew point question was a good. Oh, the chart, right.
Okay, so I don't really know. I'm trying, but I'm like stuck. This is what I think my problem is, not like really understanding what it's asking for some reason, even though it says what it's asking.
So what do you think it's asking?
I don't know. So I need to find. I mean, this is my problem. I don't feel like it should be this hard, and there's something I'm missing. Okay.
So if you just ignore that sentence completely,
Okay.
I just put that in there so people would know why if I was a student, I'm all, why the hell is he trying to get the air to 21 Celsius? I mean, I suppose it's no more random than anything else I ever ask you to calculate, but there was a reason for that. So the question really is just, if you had air at 21 Celsius with 50% relative humidity, what's the specific humidity?
8.058. And
So at 21, what's the max?
then 15.8.
And then half of 15.8 is
It says 8.058.
8. 8 times 2 is 16. So
I don't know why it says that, but I'm gonna do it again.
let's go with 15.8 times 0.5.
7.9.
I like that one. 7.9 works for me because I believe it is correct.
Well, so okay. I mean, I am using my calculator, not my brain. Trust me, I'm learning.
How did 8.05?
When I do 15.8 times, wait,
15.
51. What's 50%? Sorry, I don't know why I was doing 51%. Now
Because it's 21.
yeah. Well, that's me with only a third of my coffee in me. So
It's all about personal bests.
okay, 7.9. Yes.
Love it. Okay, so and the air, the sweaty, gross air outside has how many grams?
We decided it has 34.6
And what we want it to have is,
is 7.9.
so
So 34.6 minus 7.9. What? Come on. It's this phone calculator. 26.7 is the difference.
that's what I
right?
got.
Okay, cool.
Let's go with that. Let me paste that in there, then fix it to 26.7. Oh yeah, so I should probably be a good teacher. I'm not a good teacher. I just play one on TV. Okay, because the way we got that, I was gonna say if I just give the answer and I had no clue what's going on, 7.9 equals max divided by 2? No, times 0.5. Yeah, okay, that's good. So the air outside was 34.6 minus 7.9 equals 26. And I'm running out of room. That's cool. Why not? Make that a little smaller. Does that help? Well, okay, so if we, how many grams? Yeah, it's going to be the same kind of thing. Copy, paste. Okay, so how many grams of water vapor per kilogram of air would we need to remove to bring the relative humidity down to 50% at 21 Celsius if the air initially had a temperature of, did I update that? Temperature of 35 and humidity of 35 and a relative humidity of 95. Okay, so we started off with 34.6. Oh, wait. No. That is the correct answer to that question. It is not the correct answer to this question. Because what's the max at 21?
15.8.
Yeah.
Yeah. So if your home cooling system brings in air, and if it brings in outside air that's got 34.6 and cools it to 21, at 21 the max is 15.8.
So 15.8 minus 7.9.
No.
Oh no.
If it brings that air outside that has 34 grams and cools it to 21 Celsius. Oh, shit. No, I did it right on purpose. Ah, Remember I said I put it backwards?
Mm-hmm.
It's like that old 1970s poster. I thought I once made a mistake, but then I learned I was wrong. Right. That's what I had the question set up initially in the assignment. The assignment was correct. I wanted to say, what's the outside air? If you bring that outside air in and cool it to 21 Celsius, how many grams of water condense? And then what does perfect air look like? And then if you bring the air from outside that's all sweaty and cool it and make it perfect, how many grams of water condense? I suppose we should back up and start all over.
Maybe would be good.
Well, you got I mean, you're good up to this point, right?
Yeah, that part I think is good.
So backing up, you're given a temperature and relative humidity, you calculated out the correct specific humidity. So I went back a page.
Sorry, I'm just rewriting on a new paper so I can make better notes.
And while you're doing that, cool. So here we are. What's the dew point temperature? We figured out all that stuff, right?
Mm-hmm.
Okay. So then the outside air has 34.6 grams per kilogram because we figured that out on the last page.
Yep.
And if you bring in that air, yeah, that's
Wait,
the
just
question.
to make sure
I just deleted it. So, because that's the question. If your home cooling system brings that air inside and cools it to 21 Celsius, how many grams of water would condense? I think the reason that we got the wrong answer was because I changed the order of the questions. And so we were actually answering the questions in the order that they were written, which was wrong.
wrong.
Cool.
Okay. So
Oh, you know what's confusing, I'll bet? There's an intermediate step that I did not explicitly tell you to do that you have to do,
okay.
right?
Yes.
Because if I tell you what the characteristics of the outside air are, 34.6 grams per kilogram, and you bring it inside and cool it to 21 Celsius, how many grams of water would condense? Well, you need to figure out what the maximum specific humidity at 21 Celsius is, right?
Yes.
But it doesn't tell you to calculate that. I just ask for the answer.
So at 21, it is 15.8.
Right.
Okay. And then nine, 6 times 15 minus 15. Calculator. 18.8, yeah. I'm pretty slow this morning, clearly.
It's all about personal bests.
Okay. Not at my personal best by far right now. Okay.
Well, no, you are for now.
Could we learn about rocks and mountains instead?
Yeah.
I'm just kidding. I'm just kidding. I know we got to get through this part first. Okay, so that's just
So we've taken care of these questions. So the next question now is, what does perfect air look like?
21 degrees Celsius with 50% humidity. So that's the 15.8 times 0.5. So we know that's the 7.9.
Right.
So relative humidity. So can you just explain to me on this one? I don't know why it's confusing for me, but specific humidity of the air with 50% is,
You mean how I got that answer?
yeah, no, never mind. I know. I got it right here. I have it written down because it's times 0.5. I'm sorry.
Stop apologizing. You're doing great.
It's my biggest flaw, I've been told.
Apologizing?
Yeah.
Yeah, I've noticed in class, it is entirely normal for women to raise their hand. Yeah, if I was going to grotesquely stereotype, women in class raise their hand and say, "I'm sorry." And guys
I
just
agree.
typically just blurt out what their question is in the middle of whatever you're doing. So, yeah.
Yeah.
Thanks, society. So you're good with this, with the
Yeah.
specific
Very
humidity equals max times relative humidity.
correct.
Yeah, I think I put that someplace. I don't remember where I wrote that down recently and stuck it in one of the assignments. So yeah, specific humidity equals the maximum times the relative. So if we know the max is 15.8 and the relative is 50, 15.8, the max times 50% is 7.9 grams. And then that last question we already did.
Correct.
How many grams of water vapor would condense if you brought in the sweaty air and dried it out so that it's perfect air? I could write the questions like that.
Maybe it would make more sense to me. I don't know.
We're going to call the outside air the sweaty gross air, and we're going to call the end result perfect air.
The expensive perfect air.
Yeah. And I think, is that the oh, that's the last one for the hot and humid.
Yeah, that's the end of it.
Oh yeah, now we get to move on to the fire weather.
Yeah, fire weather.
Unless you got questions, Wyatt. I'm assuming you don't, because you speak up when you, but in the interest of inclusiveness. So fire weather. I was so happy with this one, at least the idea. So what do we know? We know we've got initial conditions. We know the temperature. We know the dew point temperature. So if we know the dew point temperature, we know what the specific humidity is, right?
Correct.
So what's the relative humidity? Because we'll know the specific and we'll know the max, so we can calculate the relative. And then the temperature changes and we have a new dew point, so we have to figure all that stuff out again. And then I'm just asking you, what's the difference between the specific and the maximum specific at 6 o'clock in the afternoon?
All right.
So I also broke this one down step by step with other pages. I'm saying that because I can see you intently looking at the screen and I don't want to move it while you're still looking.
Okay, go ahead.
All right. Man, I can hardly wait. So, see, I wrote it all big.
Nice.
Initial conditions, 20 Celsius, dew point of -10. What's the specific humidity?
20 Celsius is 0.8. Wait, what? Oh, that's because you copy and pasted. No, is that?
What? No, the copy and paste is wrong. I just wanted to keep the formatting.
Okay.
What the? Yeah.
Yeah.
Ignore this, people at home.
So
Okay.
20 degrees Celsius is 14.7. Yes, no?
What?
Are we still looking at that chart?
Yeah. So what's the dew point temperature?
-10?
The dew point temperature is -10. So what's the specific humidity?
1.8.
Yeah.
Perfect. Nicole, you good?
Yeah.
Excellent. Yeah, the initial conditions, I don't care what the temperature is. If I give you the dew point, that's enough to figure out the specific humidity. I'll bet a lot of students are going, well, at 20, you can have 14.7, so it must be 14.7. No, I'm asking what's
So we
the
just
dew
pay
point?
no mind to the initial conditions. We just
Well, no, you need
use
it to
our
figure out
people.
what the relative humidity is, right? But the question's asking you, what's the specific humidity? And at this point, if you know what the dew point temperature is, you can figure out the specific humidity. You need to know what the temperature is to figure out the relative humidity, but not the specific. If I gave you, right, because it's that deal where there's 3 parts to it. If you know the temperature and the specific, you know what the relative is. If you know the temperature and the relative, you know what the specific is. I suppose if you knew what the relative and the specific was, you could calculate what the temperature is. But in this case, the important element of information is the dew point temperature. So I'm just going to put that in bold and make it blue. So the specific humidity is 1.8 grams. There, 1.8 grams, because the dew point temperature is 10 Celsius. Okay, so now it's, what's the relative humidity? Do I have anything to paste? Yes, cool. So what's the relative humidity at that temperature? So let's start with the, let's see if I was going to go back here. Relative humidity equals specific humidity, and the specific humidity is 1.8, right?
Mhm.
So we've got 1.8. And the maximum specific humidity at 20, it's 14.7, right?
Yeah.
Nicole, did I lose you? Was I going too fast?
No. Nope. I just hadn't looked at it for myself, but I believe you guys. Now I
Good for
see it.
you. No, no, no. You should always double check everything. I always do. I'm frequently wrong.
So oh, there we go. So over 2. Yep, 12%. That's what I got. Well, 0.1224.
Sweet.
Perfect.
All right. Yeah, I'm gonna make these even smaller because I want more landscape. All right, at 6 o'clock that afternoon, the temperature was 31 Celsius with a new dew point. What's the specific humidity? And again, we know the dew point temperature is the key. I'm just going to copy that. And if the temperature is -8,
Yeah. 2.2.
yep, love it. Oh, sorry, Nicole.
That's okay.
There you go. Are you good with that so far?
Yeah.
And then relative humidity. Relative humidity equals specific humidity. So the specific humidity we know is, I'm going to copy that one because the formatting's better. So the specific humidity is
2.2.
2.2. The max is
29, because you do for 31 degrees Celsius, right?
Yeah.
Yeah, 29.
29.0. Nicole, you want to tell me what you get for the percent?
Yep. Uh, 7.58, so 8%.
Metal. Yep.
Yes.
0.75 equals 8. Outstanding. All right, so then the next one, and I think all I need is that. Yeah, no, I need those two. Copy and paste and make everything else tiny. And these can be tiny too, because we need them, but we don't need them to be big. We just need that information to solve the very last question. Which at this point should be child's play. What was the specific humidity deficit at 6 p.m.? Okay, so specific humidity minus
Come on, calculator, wake up. 26.8.
what's the temperature?
Oh,
Hang on.
okay.
Max specific humidity control equals, oh, now it's the other way around. It's max minus max specific humidity minus specific humidity. So the max is at 31 Celsius, right?
Yeah.
29.
Okay.
And we figured the specific is 2.2.
Yep.
So 26.8.
Love it. 26.8. Yep.
Cool.
Goal.
Cool.
Fantastic. Those problems are, well, yeah, I was gonna say they're structural. When I say structurally, I mean the way they're written is identical because I just copied the questions and then just used different numbers.
Okay. Well, that's very helpful, at least like the process, seeing the process and making sure I'm doing it right. That's very helpful. Cool.
Do you have any other questions?
I don't know that this is related to the lab.
Well, hang on. Let me just
Okay.
stop the recording.
Yeah.